Hi students, welcome to today's lesson which is on salts preparation. Have you ever wondered why are we even learning about the solubility of salts and how are salts even formed in the first place? So this video will serve to answer some of your questions and let's take a look at it. For this lesson, you will need two pieces of information, one a solubility table and the second one is this flowchart that can guide your own thought process on which method to choose. This might differ from what you receive from your teachers, but feel free to refer to your own notes for this entire video. We will be using these two pieces of information throughout this video. Let's look at the first example of preparation of barium sulfate salt. First, look at the solubility table and identify if barium sulfate is soluble or insoluble. As you can see, barium sulfate is actually an insoluble salt, and to prepare such salts, we have to use the precipitation method. In this method, we have to use two different types of solutions, one of which consists of the barium ions and another one that consists of the sulfate ions. So, I've chosen to use barium chloride solution as well as potassium sulfate solution for this particular example. Precipitation method involves three steps. Firstly, we have to mix the two solutions together and stir thoroughly. Then you will notice that the insoluble solid will start to form and we have to filter it as the residue. Last but not least, wash the insoluble salt with deionized water to remove impurities and pat them dry using pieces of filter paper. In example 2, we'll be preparing sodium sulfate salt. Once again, take a look at the solubility table and identify the solubility of sodium sulfate. Yes, sodium sulfate is actually a sodium salt and so it falls under the category of spent salts, which are all soluble. And the method to use is the titration method. In titration method, we have to use an acid and an alkaline, and the product will be a salt as well as water. To choose which acid and alkaline to use, we have to go back to what is the salt that we need to form. In this case, sodium sulfate. So we need a reagent that can have the sodium ions as well as another reagent that consists of the sulfate ions. And so I've chosen to use sulfuric acid as well as sodium hydroxide. And this will give me sodium sulfate and water. In the titration method, there's a total of 7 steps. In the first step, we have to fill the burette with an alkaline. At the same time, we have to pipette 25 cm³ of acid into a conical flask. In step 2, add an indicator into the conical flask. Titrate the alkaline into the flask until 1 drop of alkaline changes the color of the indicator permanently. Then record the volume of alkaline added. In step 4, repeat steps 1 and 3 without an indicator and remember to add the recorded volume of alkaline in. In step 5, we will be heating the solution until it's saturated. And next, allow the saturated solution to cool down so that crystals will start to form. Last but not least, filter to obtain the crystals as residues, wash them with cold deionized water, and followed by patting them dry using pieces of filter paper. And that is how you obtain the solid sodium sulfate crystals. In the last example, we'll be talking about the preparation of copper 2 sulfate salt. And once again, you have your solubility table as well as the flowchart to guide you. First, find out the solubility of this salt. You'll notice that there are only 3 sulfate salts that are insoluble, and hence copper 2 sulfate actually falls under the category of soluble salts. And since it is not a sparse salt, we have to use the method of crystallization. Crystallization method depends on 3 reactions that you learned in the chapter on acids. Can you still remember what are they? They are your mesh, CaSWC, as well as your AbSW reactions. And for this example, I will only focus on the AbSW example of how it can be used. So, in the preparation of copper 2 sulfate using ABSW, first we have to know what does S and W stands for. So in a reaction between an acid and a base, it actually forms salt and water. And the examples that I'll be using will be sulfuric acid reacting with copper 2 oxide, and that will give me copper 2 sulfate and water as the products. This method involves 5 steps. Firstly, add excess of the metal or carbonate or base to the hot acid. In step 2, filter to remove the excess metal or carbonate or base as residue, and you will obtain the salt solution as the filtrate. In step 3, heat the filtrate until it is saturated. And in step 4, allow the saturated solution to cool down, and you'll notice that crystals will start to form. Last but not least, filter to obtain the crystals as residues, wash them with cold deionized water, and pat them dry between pieces of filter papers. So, in this video, you have learned about the 3 methods of salts preparation. In the first one, we have to use a reagents of 2 solutions, and in titration method, we have to use an acid and an alkaline. Last but not least, in the crystallization method, we have to use an acid together with either a carbonate, a base, or a metal, depending on what is the cations present. Of course, all these can only be in place if we know what is our solubility table. So, just 2 questions before we end this video. Firstly, in the titration method and in step 4, we actually mentioned that we have to repeat steps 1 and 3 without an indicator. Can you think of a reason why? The second question for you is that in crystallization, we always heat the solution until it is saturated. Why do we not try to evaporate it until dryness? Instead, we actually heat the solution until it is saturated.